All right, guys, so we're going to continue on with this foldable that we started yesterday. So you should have the front page done and the top of the first flap when you fold it over. And this is the part we stopped on, okay, so we shouldn't have this. All right, so today we're going to talk about using sine, cosine, and tangent to find a missing side length, okay? So that's kind of one of the purpose of sine, cosine, tangent is when we want to find a side length here. But in order to do that, we have to have a couple criteria. So first, we're looking for another side length. Okay, that's our goal here. But there's a few things that we have to have in order to find that side length. So the first thing that we have to have is a right triangle. Okay, and inside that right triangle, we have to have with one more angle. So we have to know one angle is a right angle, and then we have to have another angle, and we need one side length. Okay, so we need a right triangle that has one more angle given and one side length given. Okay, and now let's do some examples. Now, when we do these examples, keep some space because we're not going to finish them thoroughly. We're just going to set them up. And then tomorrow we're going to learn how to solve them. So today we're going to set them up. Tomorrow we're going to solve them. All right, so let's look at this first example here. Okay, so we have a triangle that looks like this. Okay, so we have a right triangle. We have another angle measure. And we have a side length. And we want to find another side length. Okay, so just like what we just wrote here, we have all these, we're looking for this, okay? And at the top of everything I do, I'm going to write SOH-CAH-TOA, okay? So the first thing I want to do is I want to label each of these sides opposite, hypotenuse, and adjacent, okay? So opposite of the right angle is always my hypotenuse, and I'm just going to put H-O-N-A. Opposite of the angle we know, which is 65, is going to be my opposite, and my last one is going to be my adjacent. Okay, now I want to look at what we know. I know my opposite side is 28, and I want to know my adjacent side, which is my A. My hypotenuse, I don't know it, and I don't care to know it. Okay, that's why I didn't highlight it here. All right, so of the two that I have and that I know, I have my opposite and I have my adjacent. Okay, so I'm going to look up here at SOH-CAH-TOA, and I'm going to look to see which of these trig functions have opposite and adjacent paired together. Well, notice tangent has opposite and adjacent. Okay, so I can say that the tangent of any angle, I'm just going to call it theta, equals opposite over adjacent. Okay, so if I look down here, the angle that I know is 65, so I can say tangent of 65 equals my opposite is 28 over my adjacent, which is A. Okay, so this is where I'm going to stop today. We're going to set them up today, and we are going to solve tomorrow. So as of right now, this is what we want. All right, let's look at another problem, see if we can't set it up. Okay, so once again, I'm going to write SOH-CAH-TOA here at the right. And I'm going to go ahead and label each of these sides. So opposite of my right angle is my hypotenuse. Opposite of my angle that I have is my opposite. And then the last angle is my adjacent. Okay, and so once again, I'm trying to find the length of my hypotenuse. I have a right triangle, I have one angle other than the right angle, and I have one side length, okay? So going back to here, this is exactly what we have. All right, so I'm going to go ahead and highlight. I want to know my hypotenuse, and I know my adjacent, okay? I don't care about the opposite side. I don't have it. I don't want to know it. It doesn't matter. So right now I'm dealing with a hypotenuse and adjacent. So I'm going to look up here to SOH-CAH-TOA, and I'm going to ask myself which one of these has adjacent and hypotenuse paired together. Okay? Adjacent and hypotenuse is right here paired together. So that tells me I'm going to use cosine. So I could say cosine of any angle equals adjacent over hypotenuse. Okay? So now I'm going to go back to the triangle and I'm going to write, or I'm going to set up an equation for this. Okay, so the cosine of, well, the angle, my reference angle is 47 degrees, equals adjacent, which is 10, over a hypotenuse, which I'm just putting D. So as of right now, this is what I want. This is how I would set this up. All right, let's do one more. SOH-CAH-TOA. All right, I have a right triangle. I have one angle and I have one side length. I'm looking for another side length, so I've satisfied this. All right, let's label each of these sides. So opposite of right angle is my hypotenuse. Opposite of my reference angle is my opposite, and then the side left over is my adjacent side. All right, so once again, I'm going to highlight. I want to know my opposite side. That's what I'm looking for. And I have my hypotenuse. I don't care about my adjacent side. I don't have it. I don't care to have it. Okay, so now you're going to ask yourself, with O and H together, which one of these three trig functions have O and H together? Okay, O and H are together right here, and the S stands for sine. So I can say the sine of any angle is opposite over hypotenuse. Okay, so now I can do it with this triangle. So sine of my reference angle, 72, equals my opposite, that's my N, over my hypotenuse, which is 50. We will learn how to solve this tomorrow, but right now, this is what I want.